Okay, now you can get a graph. Like all the students, they have got the tendency to either jump to the conclusion of preload or afterload. Okay, preload or afterload graph. So you get the graph, and the first question will be comment on the graph, and you will automatically say preload and afterload. No, that's not the right way. If you start your graph, whether it is a preload or afterload, by saying this is the graph which shows the effect of change in initial length and load on, not off, on smooth muscle contraction, means effect of change in initial length and load on smooth muscle contraction. See, if we look at this graph of this preload and afterload, you have got the tendency to say this is the graph. Let me remove this ink. So this graph, this is effect of increasing initial length as well as load. So how will you say this is the preload? First of all, what is the preload and afterload? Preload is also known as free load. Pre means previously or before we are loading a particular muscle. Say now muscle preparation is there, we will stimulate this now part and make the muscle contact. But if we initially stretch this muscle out, how will we stretch initially? By providing a particular weight. Say in this 10 gram, 20 gram, 30 gram. So we hang a weight of 10 gram over here. Then what will happen? This muscle will get stretched out, and then we start stimulating. So that is preloaded muscle, means beforehand it was stretched out and then we stimulated and we recorded the contraction. So this is, if instead of the 10 we hang the weight 20 or 30, so if we keep on increasing the weight, it means we are keep on increasing the initial length. So that's effect of increasing the length as well as effect of increasing the load on skeletal muscle contraction. That's the better way to start this preload graph. Now how will you know this is the preload or afterload? See, first of all, this graph recording we are getting, it is on a stationary drum, right? On a stationary drum. Say, how will you know this is on the stationary drum? Because if the drum would have been rotating, we will get this kind of the graph, but we are getting just like the marking lever is moving upward, then it's falling downward, right? So this is on the stationary graph. The second thing is, why we are saying this is preload, means say if we look over here, this is the baseline, there is no weight applied, 0 gram, and we stimulated the now, muscle contracted, we got this response. Now what we did, we hang 10 gram weight before application of the stimulus. So what will happen, because we have hanged, say this was the now muscle, we have hanged the weight of 10 gram. Now this was the recording lever on the drum. So initially this was the baseline. Now we hang the 10 gram weight. So what will happen to the baseline? This baseline will shift downward because this is moving downward. So it will be over here. If we instead of 10 gram we hang the weight of 20, then further downward shift of the baseline. So over here we are getting the baseline shift with the increase in the weight, right? Initial baseline is would have been over here, the second baseline this, third this, fourth this. So in the preload condition the baseline is shifting downward. So it's very easy to identify whether it's a preload or afterload. If we look at the afterload graph, let me show you the afterload graph. This is the afterload graph. See, now we are increasing the weight, but the baseline is not shifting as compared to the baseline in the preloaded one. In afterload it's not shifting downward, right? So this is effect of increasing load. So for the preload we are looking for the effect of increasing the initial length on the muscle contraction. In this one, effect of increasing load on muscle contraction, though the length remains the same, initial length remains the same, right? There is a difference, like say in the isometric and isotonic contraction. You should always read about the isotonic and isometric contraction, because in any of the graph of the skeletal muscle preparation, examiner might ask you like contraction. Obviously, this is smooth muscle contraction. So isometric and isotonic contraction. Isometric is at the time of the contraction, when the muscle has contracted, the length remains same, right? But in this one, preload and afterload, in the preload, the initial length, it is increasing, but in afterload, the initial length remains same, but once the muscle has started contracting, then that effect of the load comes into play. Say, just imagine this is now and this is muscle. So we will put the setup in such a way that as soon as the muscle, because of the stimulation, we provided the stimulus, the muscle starts contracting. So as soon as the muscle starts contracting, we will add that weight of 10 gram, right? So that is the afterload, effect of the afterload. And there is one more diagram, let me show you, which will make it easier for you to understand the thing. Say this one. What is this? Say this is the fulcrum, right? And we are hanging the load over here. This is the weight, and this is just a pen marker. See, the muscle is over here, muscle is at this point, and we have hanged the load over here, right? So, and what we are getting recording is this one, like say not this, this is on the moving graph. If the graph is stable or the stationary, we will get this line, right? This line. So we are getting the recording of this line in these graphs, and but the actual movement of the load is happening this small h, right? So if I draw the diagram, let me draw the diagram this way. Say this was the load was hanged over here, and this is, it's kind of like say the fulcrum was this way and muscle contracted over here, so it moved upward. So we are getting this recording, and if this recording is depicted with capital H, so this moved from this point. So initially, actually the load moved this small h, this distance, and we know this length is capital L, right? The capital L, and this one is small l. So small h by capital H is equal to small l by capital L. That's the formula. See, we have to calculate the work done. Work done is force into distance, right? What is the force? Force is weight in gram, and weight into gravity we will calculate that is the force, and how much that force has moved. Work done is how much that force, that weight has moved. So weight has not moved this much, weight has moved only this small h. So we have to calculate this small h. So this small h will come out as capital H into small l by capital L, right? And how will we have to calculate the small h. We know the capital H. What is the capital H? If we look at this diagram, say first we will take the example of preload. So for 0 gram, this is the capital H. For 10 gram, from this baseline to maximum height, this is the capital H. Similarly for 20, this is the capital H, right? And we will be provided with this small capital L and small l. Say this will be the graph you will get, say this one. like the length of the long arm of the lever is 10 centimeter and length of the short arm is 2 centimeter, means this was the long arm and this was the short arm from where the weight is hanged over here, this much. So from this point this is small l and this is capital L. So capital L is given 10, small l is given 2, and we will calculate the capital H for 0 gram from this point to this point, measure the distance. Similarly for 40 gram from this point to this point. So we will calculate the small h, and we know the weight, force is 40 into, then we will add up the effect of the gravity, right, the effect of the gravity. Or if we are not adding the effect of gravity, because if we are taking in the centimeter, then force will be the weight in gram, right, like the weight in gram, like 40 gram, and this height, the small h, it will be calculated in centimeter. So it will come out to be 40 gram centimeter. Say if that small h comes out to be 1, then 40 gram centimeter. If you want to convert it into like say ergs, then multiply it by 981, that will be the ergs. So we will calculate the weight done with different the work done with different weight in preload as well as afterload. So what is the significance of doing this experiment, or what all the questions you can be asked? So first and foremost will be what is preload and what is afterload, that you will define, right. Now they might ask you what are the preloaded and afterloaded conditions in day-to-day activity or routine activity of the muscle. So the preloaded, the best example of the preloaded condition is the continuous contraction of anti-gravity muscle, the anti-gravity back muscles to maintain the posture, that is the preloaded. And what is the preload in those anti-gravity muscle? Gravity is the preload, right, because the gravity is continuously acting on these muscle, and to counter that effect the muscle is contracting, back muscles are contracting. So that is the preloaded condition. And can you give me the example of afterloaded condition? Yes, lifting of the weight from the ground, lifting of the weight from the ground is the example of afterloaded condition, right. Now there might be some other terms regarding the length as well as the load, like say what is initial length, what is resting length, what is optimum length, all these length are there. The resting length is the length of the muscle at which it is present under natural condition in the body in relaxed state. Like if you want to check the resting length of the biceps, if the biceps is not contracting, the length of the biceps in your body from one end of insertion to the other end of origin. So that is the resting length when it is in relaxed condition. What is the initial length? Initial length is muscle length before it starts contract. That is the initial length before the start of the contraction. Okay. So initial length we can increase or decrease in nerve muscle preparation by the application of the load. Now what is the optimum length? Optimum length, they can ask you. Optimum length is the length at which the muscle is present under natural condition at rest in the body, and at this length they develop the maximum active tension. Maximum active tension. Now because the word optimum has come into play, one is optimum length, other is optimum load. Whether it is a preload or afterload, ultimately we are calculating the work done in a particular length or with a particular load. So what is optimum load? Optimum load is, say, let me give you the example, one second. Where is that? Say this one. If we take the example of this one, say the weight is increasing right? Work done in, say, if we have to calculate the work done in 10 gram or 20 gram, say we have to calculate the work done with different weight. This is for the afterload condition. Say for the 10 gram, we have to calculate the small h, and that is equal to capital H into, what was the formula? Small h by small l was equal to capital H by capital L. So into small l by A. So this small l and capital L, it will stay constant, right? And this is the capital H, this is the capital H, that is changing. So just imagine, for the 10 gram weight, this height comes out to be 5 centimeter. For the 20, it is 4 centimeter. For 30, it is 342 centimeter. We are just taking the example, and L by L, just imagine it is 1. So the work done will be in 10 gram will be 10 into 5, right? It will be 50 gram centimeter. For 20 gram, it is 80. For 30 gram, it's coming out to be 90. For 40, it's coming out to be 80. For 50, it is coming out to be 50. So what you have noticed over here is, initially when you keep on increasing the weight, the work done will keep on increasing up to a certain point, like 90. After that, if you keep on increasing the load, the work will keep on decreasing. So this is the maximum work done in this particular muscle, the 90 gram centimeter. So this 90 gram centimeter is happening at 3 centimeter movement, right? 3 centimeters. Just imagine this is the length. So the optimum load is 40% of the load. 40% of the load, the muscle is just unable to lift. This is actually the optimum load, where the maximum active tension is developing this particular muscle, because the maximum work is done. So how will you calculate the optimum load for a particular muscle? Say, let me make it easier. आप जिम जा रहे हो, मान लो, जस्ट इमेजिन यू आर गोइंग टू जिम एंड परफॉर्मिंग ए पर्टिकुलर एक्सरसाइज फॉर ए पर्टिकुलर मसल. से फॉर द बाइसेप्स, आप बाइसेप्स कर्ल मार रहे हो, राइट? बाइसेप्स कर्ल. तो आपका ऑप्टिमम क्या है? ऑप्टिमम वेट में, ऑप्टिमम वेट और लोड वन सेम थिंग. ऑप्टिमम लोड फॉर ए पर्टिकुलर पर्सन बाइसेप्स विल बी वेयर द मैक्सिमम वर्क विल बी डन. वही ज़्यादा इफेक्टिव होगा ना. तो आप कैसे कैलकुलेट करोगे अपनी मसल के लिए? हर एक की मसल अलग अलग होती है, तो हर एक के मसल के लिए ऑप्टिमम लोड अलग अलग होगा. तो आप एक काम करना, जाओ और उस बाइसेप्स कर्ल वाले में वेट उठाने की कोशिश करो. जस्ट इमेजिन आप 100 kg वेट जस्ट उठा रहे हो, जस्ट मूव कर रहे हो, और जैसे ही वो 101 होता है आप उसको लिफ्ट भी नहीं कर पा रहे हो. सो 100 kg इज लाइक 101 is just unable to lift. So what is the 40% of the 100 kg? 40 kg. So 40 kg is the optimum load. तो आपको 40 kg पे एक्सरसाइज करनी चाहिए to get the maximum effect. Okay, did you get my point? Optimum load, what is the optimum load? Optimum load is where the maximum work is done. And how will you know the optimum load for a particular muscle? If that particular muscle is unable to lift a just certain amount of the weight, take the 40% of that. Say आपकी बाइसेप्स 99 उठा रही है, 100 नहीं उठा पा रही है, तो 100 का 40% क्या हुआ? 40 kg. That is the optimum load. That is the question you might get asked in this preload or afterload. Now, what is optimum load? Load at which the maximum work is done is the optimum load, and you can calculate it. And what all other question you might get? Why muscle efficiency is more in preloaded condition than in the afterloaded condition? Yes, you might get this question. Like the preloaded muscle is more efficient. Why? Because in the preloaded muscle you are increasing the length of the muscle. You are increasing the length of the muscle in preloaded condition you are increasing the length of the muscle. So if you increase the length of the muscle, what will happen? Say this is the relaxed one, actin and myosin filament. If you stretched this muscle out, what will happen? Say this is the stretched one and this was the relaxed one. So out of these two conditions, you have provided the preload, and this is you haven't provided the preload. With preload and this is without preload. So what is the difference? In with preload you have stretched actin myosin more out. So it means while at the time of the contraction it will get more length to travel. So more of the myosin head will get attachment with the actin, right? More myosin head will bind to the actin filament. So there will be more and more contraction force. So hence more work will be done. So we can say the preloaded muscle is more efficient than the afterloaded. Why? Because when the initial length of the muscle is increased, more of the myosin heads will bind to the actin filament, more of the contraction force will be generated, hence more of the work will be done. So that's all regarding the preloaded and afterloaded condition you might get, right?